Hire our experts for the best. Online economics exam help. To get more info, please contact us, +1 678 648 4277 or visit www.economicshomeworkhelper.com. Email info@economicshomeworkhelper.com. 1. Dale, Geraldine, Monroe, and Grover can split their time between fishing and gathering coconuts. Their production possibilities are reflected by the joint PPF below. A. What is the opportunity cost of producing the first 5 coconuts? 0 fish. In producing the first 5 coconuts, we shift from 0 at 20 to 5 at 20. Fish production does not decrease, so the opportunity cost and slope on the PPF is 0. economicshomeworkhelper.com. B. What is the opportunity cost of producing the first 2 fish? 2/10 coconuts. In producing the first 2 fish, we shift from 20.10 to 20.82. Coconut output falls by 0.2. The slope of the last segment is -10, meaning the opportunity cost of a coconut is 10 fish. This implies the opportunity cost of 1 fish is 1/10 coconuts. This opportunity cost doesn't change for the relevant range here, so the opportunity cost of 2 fish is 2/10 coconuts. C. If Geraldine has the second lowest opportunity cost of producing fish, what is her opportunity cost for gathering 1 coconut? 3/2 fish. From the labeled points we can construct the table shown below. Each segment on the joint PPF shows one person's productive possibilities. If Geraldine has the second lowest opportunity cost of producing fish, she will also have the third lowest opportunity cost of coconuts. Examining the table, person B must be Geraldine. Alternatively, the person with the third lowest opportunity cost of coconuts will give us the segment between 16 and 2010. D. How many fish can Geraldine catch if she spends all of her time fishing? 6 fish. economicshomeworkhelper.com. 2. Nowhereland is an island economy with population of 4, Alice, Bob, Catherine and David. Every day there are 2 survival activities under the northerly sea of ferocity, catching jellyfish and collecting seaweed. Both activities involve open water diving, requiring the use of an oxygen tank. Thus, a special kind of capital called oxygen tank is used in the production of these 2 goods. Each person possesses a different amount of oxygen tanks. The following table shows how many oxygen tanks each person has and how many are needed to produce each unit of the delicacies. economicshomeworkhelper.com. Alice, Bob, Kathy, David. Oxygen tank possessed, tanks, 6, 10, 8, 15. Catching jellyfish, tank/jellyfish, 1, 2, 2, 5. Collecting seaweed, tank/seaweed, 3, 5, 2, 3. A. If everyone decides to catch jellyfish only, how many jellyfish can all of them produce? If everyone decides to collect seaweed only, how many seaweed can all of them produce? If all decides to catch jellyfish, Alice, Bob, Kathy and David will catch 6, 5, 4 and 3 jellyfishes, respectively, or a total of 18 jellyfish. Similarly, if all decides to collect seaweed, they will collect 2, 2, 4 and 5 seaweeds, respectively, or a total of 15 seaweeds. economicshomeworkhelper.com. B. What are the opportunity costs of catching jellyfish for each person? What are the opportunity costs of collecting seaweed for each person? Put your answers in the following table. Opportunity cost for a jellyfish, opportunity cost for a seaweed. Alice, Bob, Kathy, David. The logic is as follows. Alice faces a trade-off of either 6 jellyfishes and 0 seaweed or 0 jellyfish and 2 seaweeds. Hence, for Alice, the opportunity cost of a jellyfish is 2/6 equals 0.33 seaweed/jellyfish, gives up 2 seaweeds for 6 jellyfishes, and the opportunity cost of a seaweed is 6 divided by 2 is equal to 3 jellyfishes/seaweed, gives up 6 jellyfishes for 2 seaweeds. The similar logic applies to the rest of the population. Here's the completed table. economicshomeworkhelper.com. Opportunity cost for a jellyfish, opportunity cost for a seaweed. Alice 0.33 seaweed/jellyfish 3 jellyfishes/seaweed. Bob 0.4 seaweed/jellyfish 2.5 jellyfishes/seaweed. Kathy 1 seaweed/jellyfish 1 jellyfish/seaweed. David 1.67 seaweed/jellyfish 0.6 jellyfish/seaweed. C. Who has the absolute advantage in catching jellyfish/collecting seaweed? Who has the comparative advantage in catching jellyfish/collecting seaweed? There is a catch here. 1. Note that the table gives the number of oxygen tanks required to complete a task, not the amount of task they can do. 2. Notice that each person has unequal amount of oxygen tanks. Hence, we need to normalize the amount of resources each person has, i.e., assuming that each has an equal amount of resources, ask how many they can produce. Let's choose 60 tanks to equate the number of oxygen tanks each person has, so the following table shows how many jellyfishes and seaweeds can be caught and collected. economicshomeworkhelper.com. Alice, Bob, Kathy, David. Oxygen tanks 6 times 10 is equal to 60. 10 times 6 is equal to 68 times 7.5 is equal to 60. 15 times 4 is equal to 60. Jellyfish caught 6 times 10 is equal to 65 times 6 is equal to 34 times 7.5 is equal to 33 times 4 is equal to 12. Seaweed collected 2 times 10 is equal to 22 times 6 is equal to 12. 4 times 7.5 is equal to 35 times 4 is equal to 20. With the same amount of resources, clearly Alice has the absolute advantage in catching jellyfish and Kathy has the absolute advantage in collecting seaweed. Using the table in Part B, since Alice has the least opportunity cost of catching a jellyfish by foregoing only 0.33 seaweed, she also has the comparative advantage in catching a jellyfish. Similarly, David has the least opportunity cost of collecting seaweed, thus, he has the comparative advantage in collecting seaweed. D. Determine the acceptable range of trading price for one jellyfish in terms of number of seaweed. Determine the acceptable range of trading prices for one seaweed in terms of number of jellyfish. economicshomeworkhelper.com. The acceptable range of trading price is the difference of the lowest and highest opportunity costs in doing something. Hence, the acceptable range of trading price for one jellyfish is between 0.33 seaweed, 1.67 seaweeds, and for one seaweed is between 0.6 jellyfish, 3 jellyfishes. E. Label seaweed S and jellyfish J on the x-axis and y-axis, respectively. Give the equations for the ppfs of each person and plot separately. The equations for individual ppf are: Alice J equals 6, 3s Bob J equals 5, 2.5s Kathy J equals 4, s David J equals 3, 0.6s. F. Draw the joint ppf for Nowhere Land. Clearly mark and give the locations of the kink points. Write down the equation for each segment of the joint ppf. economicshomeworkhelper.com. This is not a trick or math question. Just simple economic logic is more than enough. To draw a joint